Today we're going to talk about reflections. And in geometry, reflection is a mirror image. So just as if you're standing in front of the mirror and you see your reflection, everything is backwards. Or if you take a picture with yourself on the phone, it can be reversed or reflected. So things look backwards. So what we're going to talk about today is how we do reflections and what they look like in some notation. So you'll see an example here of triangle ABC in black. It has been reflected across the yellow axis, the y-axis here in yellow, to now figure ABC, and you'll notice some other little notation. We'll talk about the notation in a second. So that takes the points, so the point that was here at A is reflected across this line to now be over here at A, what we call A prime. They're the same distance from the line. So if we look here and we see, we count 1, 2, 3. It was 3 away. And if we look now, 1, 2, 3 away. If we look at C, it was only 1 away, and now C prime is 1 away. B originally was 2 away from the y-axis, and now it is 2 away on the other side. So if we would be able to pick this paper up and fold it in half right along the y-axis, these would be exact mirror images of each other. The points would line up on the opposite side of each other. And one thing to remember is they're the same distance from the line. So let's talk about the notation. So you notice that one is labeled ABC and the other one is labeled ABC with like a little check mark above it or a little 1 above it. That's not an exponent. This is a notation. So notation is very important to know. It tells us what the pre-image is, and which is the original image, and once it's moved, we call it A prime. So let's look at our example here. So we have a little square here, and we just called the whole square A. When we move it or reflect it across, in this case, we reflected it across the y-axis, we moved the whole figure over 2, 1, 2 from the line, and it's 1, 2 away. Because we made one move, that's called A prime, and we put A with like a little stick above it or a little 1 above it. Some people do a little comma. It's A prime. If we move it again, the same original figure, we move it again. This time we went across the x-axis, so I went across the x-axis here. It is 1 away, and now it's 1 away. Because I moved it the second time, it is A with 2 little lines. That's called A double prime. So we use this notation to help us know what the original was, or the pre-image, and what we've done to it, how many times we've moved it from its original position. And that'll be very helpful when we're doing multiple steps of movements. All right, so let's talk about things that happen in reflections. So we're going to start with just a point. So we have point A here, and point A we can see is at -3, 3. So we're going to reflect this one across the y-axis. So you have to know where your y-axis is. That's very important. So I'm going to highlight our y-axis here in yellow. Our y-axis is here. So this is a good strategy to use. I always start with knowing what axis you're going across. That's usually a mistake people make. So we're going to look and see how far away are we from the y-axis now. When we look, let's use a red color so we can see. 1, 2, 3 away. So we want to mirror it on the other side and take that point the same distance away, but in the mirror image across this axis. So we're going to go 1, 2, 3 away. And our new point is now going to be here. We will call this now A prime because we've made one move. It's not the original image. It's now been moved one time. So we call it A prime. So let's look at the coordinates of this one. This is 3, 3. So I want you to notice something about the coordinates. Originally, the X value was a -3. Now it's a +3. The Y value was a 3 originally, and it's still a 3. The Y's didn't change. So when we move across the Y-axis, the Y coordinates stay the same. And the X coordinates change. And look how they changed. They changed by going into the proper quadrant. Remember, in quadrant 1, which is where our A prime is, that is a positive x. So the x coordinates change to match the quadrant. And you can also think about their opposite. One started negative, and now it's positive. So it's opposite. So if you're going across the y-axis, the x-coordinates change to the opposite sign. So if it started as a negative, it becomes a positive. If it started as a positive, it becomes a negative. The y's, however, stay the same. All right, let's look at reflecting across the x-axis. So this time we're going to do a shape, and we're going across the x-axis. So let's first highlight our x-axis so we know exactly what we're going across. And we have to think of every single point. We can't just move one point. It's got to look exactly the same, just a reflection like in the mirror when we get across the axis. So we got to take each point individually. So let's first start at A. So we're 1, 2, 3 away. So 1, 2, there's our new, and label it A prime. Now let's look at B. We can see that we're 5 away because it's at 5. We can also look at this is coordinate 5, 5. So we know this is 1, 2, 3, 4, 5 away. So we got to be 5 away here. 1, 2, 3, 4, 5. So this is going to be our B prime. Let me erase some of our little marks here so we don't get confused. All right, and now let's do C. So C is 1, 2, 3 away. So it has to also be 3 away from the other side of the x-axis. 1, 2, 3 away. Now, let's label it C prime. And then we're going to connect it so we can see our shape again. All right, so now we have the reverse or reflection image across the x-axis. Let's look at our coordinates. This one is now 5, -3. Originally it was 5, 3. We already did B, originally 5, 5, and now it's 5, -5. A originally was 3, 3, and now it is 3, -3. So if we look at our original image, we had A was 3, 3, B was 5, 5, C was 5, 3, and now we moved them or reflected them. We did a movement, so our notation is now A prime, B prime, C prime, and our new coordinates are 3, -3, 5, -5, and C is 5, -3. Let's look and see what we notice. We went across the x-axis, and if we notice our original coordinates in our x was 3, 5, and 5, all positives. And our new one, it's still 3, 5, and 5. The x's stayed the same when we went across the x-axis. So the x was the boss because that's where we were crossing over. He got to stay the same. However, look at our y-coordinates. All of those changed to the opposite signs. We had a positive, it changed to a negative, a positive to a negative, a positive to a negative. So when we go across the y-axis, the x's have to change. When we go across the x-axis, in this case, the y's have to change. So think about who you're crossing. That's who the boss is. They make the other one change. Now, occasionally you'll have to go across something called y equals x. So y equals x is a line that we have that is literally every time y equals something, x equals the same. So think about this. If y equals 1, then x is going to equal 1. If x equals 2, y is going to equal 2. If x equals 0, y equals 0. If x equals -1, y equals -1. So the line that we're talking about here literally goes right through the middle of the origin at a diagonal. Okay, so this is called y equals x line. Your line of reflection can be anywhere. We could have it right here, and we could call this line L, and we need to reflect across it. So these are some major ones that you see, and we'll talk a little bit more and see some examples in Khan of other ways that you'll see it. All right, now we've moved to a paper copy. So I made the same exact image on some paper to help you see a little bit. If it's on your computer, you can do this the same way and use your computer on this on your computer. So this is what we call patty paper. It's actually the kind of the see-through paper, like almost a tracing paper that you actually put between meat patties at the grocery store. But if you don't have this at home, you can use tracing paper. You can use plain paper, especially if you put it near light, you can see through it better. You can also use a plastic bag, like a sandwich baggie that you can see through, an expo marker. You could use a piece of wax paper or parchment paper. Ask your mom if they have some in there. They always have something that could help you with that. So what you do is you lay your paper over top of your image. You want to have a registration mark. So I always put an X right across my origin, and then I kind of drew my line just a little bit that I'm reflecting over. Then I trace my shape and label it the way it is, A, B, C. Well, I know I'm reflecting, so I know it's going to end up over here somewhere. So I literally can take my paper, pick it up, turn it over, reline up my registration marks, and then I can see where it's going to end up on the other coordinate. So when I look at my other coordinate, I can see through it. I'm going to barely pick it up and put a pencil mark at each spot that it is. And I'm going to notice this is A prime, and then B prime at the top and C prime. So when I put my first registration mark, here's my C prime, here's my B prime, and then my A. Got off a little bit on my spot, my A prime. And I can connect them together. And when I look at my shape, notice that it's kind of turned. It's a different orientation. The shape hasn't changed, the size hasn't changed, but the orientation has changed because instead of going across Y or X, I went across Y equals X. So I literally flipped this way. So I'm going to now look at what my coordinates are. So my A prime, my coordinates are 2, -5 for my A prime. My B prime is 2, -3. And my C prime is 1, -4. So let's look and see what happened. Notice originally it was -5, 2, and now it's 2, -5. And here it was -3, 2, and now it's 2, -3. And the same thing here. They literally have flipped positions. We literally just take and flip their spots. So Y is now X, and X is now Y. So they flip positions. So Y becomes X, goes to X, and X turns into Y in the new situation. So you could have something where you may have a shape that goes across Y equals -X. That just means that your line would be going this direction and your shape would go across this line, or vice versa. The same patty paper trick will work, and it will also work when you're working with Khan or any shape. There will be occasions that you do not have a grid that you may have to move shapes across. So we're going to look at this shape here. So we have, and this is in our extended packet, so we have a shape of reflections here, and I notice I have A, B, C, D. This is my original shape, and I want to go across this line here. There's no grid, can't see anything. I can still use my patty paper. And in this case, I want to try not to use the middle of the paper because I can use it multiple times. So I'm going to trace over my line, and you don't have to be an artist or be perfect. Just try to be as precise as you can, but you don't have to be perfect. And then I'm going to trace quickly my shape. And I want to make sure I label my shape so I know what points go with what, so when I get to them to relabel them, I have them right. So now I have it traced, and I'm going to flip or mirror across this line. So I pick my paper up, flip it over, line it back up with my registration marks, and then I can hold it down with my registration, pick up my edge, and then I'm just going to put a little mark at each corner. Now you can also bear down kind of hard and retrace over it and kind of have an image. And some of you may have done that before where you kind of bear over it hard when you're tracing something. And then you have an image on your paper. So we have here, here, here. We're going to go ahead and connect it. And then where we were labeling it before, we have to make sure we label it. So this part here is now the A prime, B prime, C prime, and D prime. So you can see, and if we were to pick up the paper and fold it in half, if we folded it right down the center, they would touch each other and mirror. All right, let's look at a couple of the constants. We're going to do one from each one so you understand how to work it. So this is reflecting points. You have a point that's on your graph. It is labeled as A, and then the line here is what you're going to reflect across. So it says plot the image of point A under reflection across line L. So they're calling this line L here. And we're going to move this point as a reflection. Now, let's say, for example, we take and we just put a dot right there. That's not the correct way. And if we do that by mistake, we need to drag that dot to the trash can. We don't want to put unnecessary dots. If you have different dots on here that are not the proper answer, it will count it wrong. So if you have extra dots or something, you need to drag them to the trash can. So we're going to look and we're going to say we have, and you do have a little function here that you can use to write and use it to count. So you can do 1, 2, 3, 4. We're 4 away from that line, so we got to be 4 on the other side. 1, 2, 3, 4, and let it go. That is where our dot is. So then when we check it, we know we're correct. So that is reflecting across the line. That line can be in any direction. If it's something diagonal and you need to use your patty paper, you can actually use it on your screen and put it on your screen and then reflect like I showed you how to do with the paper. The next type, reflecting shapes. So when you reflect shapes, you're going to be given a shape, A, B, C. Could be any shape, could be a weird polygon, could be quadrilateral. This is a triangle. So we're going to plot the image of triangle ABC under a reflection across y-axis. Remember to always think about what axis you're doing first. This is your y. You're going across this axis right here. So we're going to cross this y-axis. So this point is what we're going to move. So this, when you move it, if you were trying to move this over top of it, sometimes it kind of stops you. So you just need to play around with this the first time you use it. So you need to do each point. Notice that B is 2 away from the y-axis, so we need to be 2 away over here as well. Now you can look at the rules. We talked about how x's and y's change with the coordinates and use that as well. So for C, if we look, it's on the third line, and it is actually over at 5, so it's 5 away. So this one has to be 5 away, so it's going to be at -5. Then we look at A. It's 2 away on line 2. So we know it's going to have to be at 2 away, line 2. And then we're going to check. And so we know we're correct. Notice that this line here is movable. So it says draw the line of reflection that reflects ABC. So here's ABC onto A prime, B prime, C prime. So we want to know what line did that cross to go from this blue one to this pink one. So we have to move our line. So if we think about where our line would be, this is 1 away from this line, this is 1 away. This is 2 away, this is 2 away. This is 1, 2, 3, 4 away, and this is 1, 2, 3, 4 away. So this is the line of the reflection that would be. So in this case, this is where we would put our line. And check, and we see that we're right. So you'll practice with some of these. Remember to be very cautious on moving your little tools, and you'll do a great job.